Welcome to 2.3. This is slope. We're going to find and use the slope of a line and graph parallel and perpendicular lines. So we're going to start with some vocab. Slope is the ratio of the change in y coordinates to the corresponding change in the x coordinates. Our key concept here. So the slope of the line is the ratio of the change. So the slope is y2 minus y1 over x2 minus x1. And we call slope m lowercase m. Now where x1 is not the same as x2 because you can't have 0 in the denominator. Here is the slope as pictured. Notice it's the rise over the run. Okay, so our first example, we're going to find the slope passes through -1, 4 and 1, -2. So we're going to start with the slope formula. We're going to substitute our values in. x1 is -1, x2 is 1, y1 is 4, and y2 is -2. So we substitute our values. -2 minus 4 is -6. 1 minus a -1 is 2. We get -6 over 2. And we simplify to -3. So the slope of the line is -3. We are now going to graph the two ordered pairs and draw the line. Use the slope to check your graph by selecting any point on the line. Then go down 3 units and right 1 unit, or go up 3 units and left 1 unit. The point should also be on the line. So here we got -1, 4. If we go down 3 and right 1, then we do connect on our line, and this graph does work. Our second example, we're going to use slope to graph a line. We're going to graph the line passing through -4, -3 with the slope of 2/3. We're going to start by graphing the ordered pair -4, -3. Then according to the slope, we're going to go up 2 units and right 3 units. And we're going to plot the new point, which is -1, -1. You could also go up 3 units and then, go right 3 units and then up 2 units to plot the new point. We're going to draw the line containing the points. So this is what our line looks like. Alright, a quick concept summary. Rate of change is slope. It's how much a quantity changes on average relative to the change in another quantity, often time. So here, if the line rises to right, then the slope is positive. So this is a +1 slope. If the slope is horizontal, then the slope is 0. If the line falls to the right, then the slope is negative. This is a slope of -1. If the line is vertical, then the slope is undefined. Something divided by 0. Right. So here's the rate of change. We're going to refer to the graph to the right. We're going to find the rate of change of the number of people taking cruises from 1985 to 2000. So we're going to start with the slope formula. We're going to substitute our values in. Our x2 is 2000, or x1 is 1985, or y2 is 6.9, and our y1 is 2.2. 6.9 minus 2.2 over 2000 minus 1985 is about 0.31 million people per year. So between 1985 and 2000, the number of people taking cruises increased at an average rate of about 0.31 or 310,000 people per year. Because remember, this is in millions. This graph is in millions. That's 6.9 million, 2.2 million. So about 310,000 people per year. Alright, some more vocab here. Family of graphs. Group of graphs that display one or more similar characteristics. And a parent graph is the simplest of the graphs in a family. So it's the base graph, the original one. So here, key concept is parallel lines. You have non-vertical lines with the same slope are parallel. All vertical lines are parallel. So our parallel lines, graph the line -1, 3 that is parallel to the line with the equation x plus 4y equals -4. So the x-intercept is -4 and the y-intercept is -1. According to our graph up here, if we plugged in 0 for x and 0 for y. So we're going to use these x-intercepts and y-intercepts, and gives us this original graph. So we're just graphing the original equation. So now I'll find the parallel. The line falls 1 unit for every 4 units it moves to the right. So the slope is -1/4. So we found that out from the graph. Now we're going to use the slope and the point -1, 3 to graph the line parallel to the graph. So we're going to start at the point -1, 3, and then we're going to use the slope of -1, 4. So that creates our new graph. So you graph the original, find the slope, and then graph the new. Okay, perpendicular. Two lines are perpendicular only if their product of their slopes is -1. So the idea is it's the opposite reciprocal. So the slopes are opposite reciprocals. So our example 5, we want to graph the line through -3, 1 that is perpendicular to the line equation 2x plus 5y equals 10. So the x-intercept of our equation of 2x plus 5y equals 10, the x-intercept is 5, the y-intercept is 2. We're going to use the intercepts to graph. And so the line falls 2 units for every 5 units it moves to the right. So the slope is -2 fifths. The slope of the perpendicular line would therefore be 5 halves. We're going to start at -3, 1, and we're going to go up 5 units and right 2 units to use this point, and -3, 1 to graph the line. Okay, so the one going down, that's our original line. The one going up is our new one. That's it for slope. Good luck on the practice.